Good evening. Glad you logged on, and let's see if we can get you some help with the homework. This is lesson 14.2. I'm going to start with number 3, the first one that you were assigned to do. So let's read through the problem. A line passes through the point -4, 5 and has a slope of -3/2. Graph the line on the coordinate grid and find one other point the line passes through. Well, first of all, they've already graphed it for us, so half the work is done. So let's look at this point. They told us this passes through -4, 5. Well, starting at the origin, I'm going to go left, -4, 1, 2, 3, 4, and on the y-axis up 5, 1, 2, 3, 4, 5. So they're talking about this point right here. They tell me that the slope of this line is -3/2. I want to check that out just to make sure they're being accurate. Let's see. So -3/2, this means my -3, I remember, is my change in y, and the 2 is my change in x. So that would mean I would go down 3 on the y-axis and right 2, and I should be at another point on the line, and indeed I am. I can continue to do so. Down 3, right 2. Oh, there's another point. Well, I think I'm at the point, so to say, point again, that I can give another point on the line, because it asks for another point on the line. So what about this one right here? What would the coordinates of it be? So I'm going to think about what's the x value. Starting from the origin, I move nowhere, so that's 0. What's the y value at this point? Well, I go down 1, so that's -1. I have lots of other options all along this line, although I would make sure whatever you choose is at an intersection that's easy to read. For instance, I could have chosen this one. Right here, I can see that it has an x value of 2, because I would have gone right 2 and down 4. So that would have been 2, -4. So again, several options there. Number 4, well, it doesn't say it explicitly. I think they wanted you to understand that this equation, in A, -3/2x minus 1, is the equation of this red line here. Okay, you might notice that the slope is -3/2, which is what we talked about being the slope of this line. So what does it mean? -3/2x minus 1 equals -1. And they want me to use the slope triangles to solve the equation. Again, a little strange wording, perhaps, but really, what is it really saying? It wants me to know, what don't I know yet? Well, I don't know what x is. So really, I'm being asked, what is x? What do I know? When y, what do I know y is? Right here's my y, guys, is -1. That's the question. And as far as using my slope triangles, I'm really just talking about using my graph over here. So let's think about it. Where is y -1 on this line? Well, here's -1 on the y-axis right here. Oh, I am right on the line. What is the x value here? Well, we already identified this as x equals 0. So the solution to this, x equals 0. I can check this out. -3/2 times 0, if I put 0 in for x, well, that's going to be 0. Minus 1, well, -1 or -1 equals -1. I'm good to go. We can do the same thing with part B. Same equation, talking about this red line over here. So again, ask yourself, what am I trying to find out? Again, I'm trying to find out what is x, when y is, and what is it? Yeah, it's -10. Okay, so let's go find y -10. Ooh, down here on the y-axis. Well, there's where y is -10. But remember, I have to go over to where my line is. Oh, right here. Right here is where y is -10 on my line. So what is the x value there? Oh, I've kind of gotten messy here. You guys are used to me getting messy. This this is 6. So this is the coordinates 6, -10. So what's my solution? What is x when y is -10? Well, x equals 6. Okay, hope that helped on those. Let's move on to the staying sharp problems. Let's make this a little bigger. Aha. I bet you guys don't really need any help on this. You've been blowing these up in the class. I'm supposed to solve for k. What does that really mean? Means I want k alone. I want to know what the value of k is that makes this equation true. So what's the first thing I'm going to do? Well, I'm going to draw my balance scale. I'm going to choose to solve this algebraically. I'm going to think about what's attached to my k. Well, 5's attached. How's it attached? Well, it's attached with multiplication. So how am I going to disconnect it? Well, I need to do the opposite of multiplication, which is divide. If I divide this side by 5, I also need to divide this side by 5 to keep the balance, to keep it equal. Let's figure out what we've got left here. Well, 18 divided by 5. Well, I'm not going to get just a whole number. I know 5 will go into 18 evenly 3 times, because 5 times 3 is 15. Gives me 3 left over, so that's 3 3/5. I know, don't be afraid of that fraction. I like fractions. 5 over 5, we know those simplify to 1. And there's my answer, guys. 3 3/5 is equal to k. For those of you who did it on the calculator, 3 3/5 is the same as 3.6 or 3 6/10. So that is an equivalent answer. Okay. Also assigned number 2. Oops. I wanted it a little bigger. Come on. Okay. This is an oldie but a goodie. We're given this equation. Complete the coordinates of the x and y intercepts of the line with the equation 20x plus 50y equals 200. I'm going to rewrite it over here. Okay. So let's think about, they even give us a little hint as a reminder about the x-intercepts and the y-intercepts. Anytime we have an x-intercept, we know that the y value at that point is 0. So if you guys remember this strategy, if I think of putting in 0 for y, that's what happens when I multiply 50 by 0. Well, 50 times 0 is 0. It's like I can ignore this term over here right now. So now I'm left with 20 times what equals 200. So 20x equals 200. So what number is that? Well, I can undo that. Think 200 divided by 20 rather, and that is, oh yeah, you guessed it, 10. So in the x-intercept, the value of x is 10. Awesome. Okay. Y-intercept, same type of thinking. What did we learn about y-intercepts? We learned at that point the x is always 0. So again, I can think of my x as being 0. Well, what's 20 times 0, guys? Yep, you guessed it, 0. So what happens to this 20x? Pfft, gone. Hide it. Cover it up. What am I left with? I just really have to think about what 50y equals 200 is. In other words, 50 times what is 200? So really, if I'm thinking 50 times what equals 200, I can think about how am I going to undo that? That's really just 200 divided by 50. What is y? Well, that's 4. 50 times 4 equals 200. So what is my y-intercept? It's at 0, 4. Do you guys remember that now? And on to the next one. I think you guys had something similar to this one on the last assignment, maybe? I like this because, guys, these problems show up a lot on standardized tests. And And as you're looking forward to college or a technical school, it's definitely going to be the types of questions that you're going to be faced with. When I read this, I think I see a couple of places where that might be stumbling blocks. So let's read it. Two numbers have a sum of 14 and a product of 33. Find the two numbers. Use whatever method you like. So guys, I'm going to just use, I would just call it reasoning and then kind of guess and check. For me, two numbers have a sum of 14. First of all, I have to know what the word sum means. Sum just literally means when I add these two numbers, let's use little boxes. When I add those two numbers, they have to equal 14. Yep. Product, there's another key term, means the answer I get when I multiply. Okay? If you guys look on the backboard when you come in tomorrow, you might notice that there's actually a little key for words that mean add and multiply on the backboard. So that means these same two numbers, I have to be able to multiply them and get 33. So find the two numbers. Well, I'm going to start with this multiplication, guys, because I don't think there's a whole lot of numbers that I can multiply together and get 33. So I'm going to start making a list. So, and I like organized list. So let's say if I start with 1. 1 times what would give me 33, guys? Yep, 33. Now, I'm also going to think in terms of, can I add 1 and 33 and get 14? Not a chance. Not going to happen. Okay, can I multiply 2 by anything and get 33? No. What about 3? Yeah, 3 times 11 is definitely 33. Liking it. What about 3 plus 11? Do I get 14? Bingo. I do. I think I just found my two numbers. 3 and 11. All right. And here's our last one. Can you believe it? Really not taking us that long at all. Okay, this is kind of a blast from the past. We did this in 8th grade. Probability questions like this, again, another common thing that shows up on those standardized tests. You should be able to work with them. This is a graph of the eye colors of students in class. They want to know the probability that if we went in and chose any student that in this class, that student would have brown eyes. So we can see in our graph, we can see the number of students on the y-axis. We can see green, blue, hazel, brown as far as different colors. Well, the first thing, before we can find the probability, we need to know how many students we're talking about. How do I find that? Well, let's look at the graph. Green, the bar is this high. I would say that's 1 student. Now, really, I'm kind of having to estimate here, but I think that's a reasonable estimate. Blue, 4 students. Hazel, estimating that at 7. Brown, estimating that at 11. Okay, what do I need to do with those numbers? I need to add them up so I know how many students are in the class. When I do this, 1 plus 4 is 5, plus 7 more is 12, plus 11 is, 23. 23 students in this class. So, out of those 23 students, oh yeah, I'm writing a ratio. Out of those 23, how many had brown eyes? Oh, we said 11. Looking a little more familiar now. Yeah. So guys, what is, I need a calculator.
Action.
Okay guys, so now I'm going to evaluate this. I'm going to turn this ratio into a decimal. 11 out of 23 is, whoops, I should have used approximate, about 0.48 of the class. I'm going to turn that, so I can say not quite half the class, about 0.48, or I could say 11 out of 23. I can even write this as a percent by multiplying the decimal by, yep, you're right, 100. And that's 48% of the class. Brown eyes. I wonder if brown eyes are genetically dominant. Wonder what color Mrs. Norton's eyes are. All right, that's it, guys. Thank you for working really hard on the assignment. We'll see you later.